Um, One student asked, it's worth mentioning, was George Lemaitre the only person to come up with the idea of a day without a yesterday, or what eventually became called the Big Bang Theory? Was he the first person? And the answer to that question is basically yeah. In fact, his contributions have been somewhat overlooked over time, and in favor of Hubble, who sometimes is credited with developing the Big Bang Theory, but Hubble simply produced the observations that showed that the universe was in fact expanding. Lemaitre had came up with the idea before Hubble had made all the observations. Also Alexander Friedman, who's mentioned in the book, but Lemaitre worked it out to a greater extent. A student asked, what started the Big Bang? What caused the Big Bang? And the answer to that question is, well, this is where you get into really speculative stuff. But perhaps the short answer would be, well, we don't know. Okay. If you're religious, you can say, you'd be like Pope Pius XII and say, God started it. Okay. But from a scientific perspective, remember Riccioli and his argument against the idea. Remember when there was this belief that, the Copernicans had argued that the stars were all huge. And why is that? Well, because God made them that way. And Riccioli, who was himself a religious man, said, well, sure, you can always use that argument, but that doesn't satisfy the prudent person. Okay, we want something more than just, why am I here today? Well, because God wants me to. No, I drove a car here, and so on and so forth. That you can provide explanations for this sort of thing. And so, scientists have tried to come up with explanations that it's a quantum fluctuation. Someone asked, what's quantum stuff? And that's beyond this class. Okay, but it's supposedly a random event that creates something. But the problem is then, well, where did quantum mechanics come from? Okay, where did the laws of physics that we use to determine how would the universe have formed from a random event? And of course, from what we learned about chaos theory, random isn't really a thing that exists anyway. Then, our multiverses. Well, we've talked about the problems that you have with multiverses, or anytime you have an infinite number of cycles or an infinite number of this, maybe it's some part of some cycle. So usually the idea is to, from a scientific perspective, is to look for some way to get rid of the beginning and go back to Aristotle. Right. If you can go back to Aristotle and say this is all part of some cycle that just occurs over and over and over again, then you don't have to answer these questions. Right. Beginnings are really hard. And as a student last semester said, cycles are safe. So that's where you see the scientific theories go, like Steinhardt and Turok, and the sort of infinite expansion theory and stuff, is to try to to get back to the idea that, well, there is no beginning. The universe simply always has existed and always will exist, and you don't have to deal with that. Of course, that runs into its own problems. There's no easy answers to this stuff. Okay, what we're here to do is to talk about, like, why do we think the things we think. And then, why do people come up with these theories, right? And, not to try to make this sound like everything's known, because it's not. Somebody asked, what if Henrietta Leavitt's idea about standard candles is being calculated? What if the calculation is wrong? What does that do? If you miscalculate the distances with the standard candles, you can find out that things are closer or further away than you thought, which would change your results. Okay, so in the football field up here, if all the yards are marked wrong, and in fact it's not 10 yards between the lines, but actually 20, then all the distances are twice as big and all the times will be twice as great. But the general picture is still the same. Things are still moving away. You can still calculate a beginning time. It's just going to be like 60 minutes instead of 30 minutes. So those kinds of problems can result in us having the details wrong, but they're not going to change the big picture. Another person asked, how could the remnant heat still be detectable in the universe from 14 billion years ago? The answer to that question is that the universe initially, when it's small and dense, right after the Big Bang, when the material's just there expanding, it's hot, dense. Okay, so it's incandescent, like a piece of iron or a star. And so it has a very particular spectrum. It has a continual spectrum. As the universe expands, where's the heat going to go? It can't leave the universe, okay, because what is there? The universe, that's it. So the heat's got to still be around in a sense, okay. Let's see. I think I'm getting most of the questions that people have had, and I think I can keep it. Did the discovery of that cosmic microwave background, that remnant heat, is that what made the Big Bang theory accepted? Yeah, that was a big thing in favor of the Big Bang theory. It's very hard to explain how, if the Big Bang did not occur, that stuff was there. There are people who have argued that no, it's actually some formation of something or another else, but that is a very minority opinion. Generally, the idea is like, yeah, we believe that the cosmic microwave background is the remnant heat of the beginning of the universe. So I would say that yes, the cosmic microwave background is the thing that really brought about the acceptance of the Big Bang theory. I think I've got just about everything that people have asked for that I have written down. Dark matter. Oh, someone said, is dark matter energy the same as dark matter? No. Okay. Dark matter is something that has gravity. It's it's thought to exist within galaxies. All right, helps hold the galaxies together. Dark energy actually spreads things, helps drive the expansion, and helps cause the universe the galaxies to spread apart from each other. Okay, so they are not the same, but they are both unknown. A person asked an interesting question, maybe not directly related to that, but it's like, what is the shape of the universe? Is the universe a sphere? And I would say yes. Okay, the observable universe is a sphere. So we'll get back to dark matter and dark energy. We can only see out a certain distance. Okay, in theory, only 14 billion light years away, because that's all the distance there is. That's all the time that's existed for light to reach us. So we cannot see something. If there's anything out there further than 14 billion light years away, if there's something out there 20 billion light years away, we won't know it because the light hadn't gotten to us yet. Okay. So oddly enough, we sit at the center of the observable universe that we can see, and the observable universe is made up overwhelmingly of dark matter and dark energy, which are materials that we don't even know what they are, right? And so in a very real sense, we're back to being Aristotle, where Aristotle thought we were at the center of the universe, and the universe was made of the fifth element, which was something we didn't know what it was. He just invented the idea to explain what we see. The same thing is true now. We're at the center, and the universe is overwhelmingly made up of material that we've just sort of made up names for because we don't know what it is. Okay, so a couple thousand years of history and of science, and in some ways we've not really made a whole lot of progress. All right, I think. I think that is about it. So, hope this helps. Now you need to answer your questions on your Part 2 forms and send them in to me. Thank you. Goodbye.